Today I'll be showing you how to do implicit differentiation, which is essentially finding the derivative of an equation that's written both in terms of x and y. Or it could be written in terms of other variables, but the key point is that it's written in terms of both the dependent and independent variable. So here we have the problem x squared plus y squared equals 25. Find dy dx. So how would you find dy dx of this equation? Well, what you have to do is you have to differentiate both sides of the equation with respect to the variable at the bottom of the fraction. So in this case x, we need to differentiate both sides with respect to x. So that means that we're going to surround the whole thing in brackets, and we're going to be taking d over dx of the whole equation. And what that means is that we're going to differentiate like normal, but every time we differentiate a y term, we're going to multiply it by dy over dx. So starting off, differentiating x squared is 2x. And next we differentiate y squared, so that's 2y. But because we just differentiated a y term, we have to multiply it by dy over dx. And then we can keep going. So differentiating 25 is just 0. And now to get dy over dx, we can just rearrange it just like you would with a normal algebra equation. So first off, we can take 2x from both sides and turn it into 2y dy dx equals negative 2x. Then we can divide both sides by 2y. And therefore, dy dx equals negative 2x over 2y, which equals negative x over y. Right, what about this one? X squared y plus y cubed x equals 10. Find dx over dy. So this time it's not asking for dy over dx, it's asking for dx over dy. So y is at the bottom. That means we need to differentiate with respect to y. So we're going to take d over dy of this whole equation. So now let's differentiate. First we can differentiate x squared y using the product rule. So that's just going to be x squared times 1, because 1 is the derivative of y, plus 2x y. And because we just differentiated an x term, we need to multiply this by dx over dy. Next we can move on to differentiating y cubed x using the product rule. So the derivative of y cubed is 3y squared. And then we multiply that by x. And then plus y cubed times 1, because that's the derivative of x. And then because we just differentiated x, we need to multiply it by dx over dy. And then that just equals the derivative of 10, which is 0. And now we just need to solve for dx dy. So first I'm just going to make it look a little bit cleaner by writing it as x squared plus 2xy dx over dy plus 3y squared x plus y cubed dx over dy equals 0, so just getting rid of the 1's. And now we can start rearranging to solve for dx over dy. So first I'm going to move all the terms that don't have a dx dy in them to the right side. So we can subtract x squared and subtract 3y squared x from both sides, and turn it into 2xy dx over dy plus y cubed dx over dy equals negative x squared minus 3y squared x. And now we can take out a factor of dx dy on the left hand side and write it as dx over dy times 2xy plus y cubed equals negative x squared minus 3y squared x. Then we can divide both sides by 2xy plus y cubed, like this. And that means that dx dy equals negative x squared minus 3y squared x over 2xy plus y cubed. Alright, how about this last example? Sine of xy plus x equals y. Find dy over dx. Because it's dy over dx, we're going to differentiate the whole equation with respect to x, so d over dx. So let's begin. First, what's the derivative of sine of xy? We start with the derivative of the things inside the brackets, so we can take the derivative of xy using the product rule. So that's going to be 1 times y plus x times 1, and because we took the derivative of y here, we need to multiply by dy over dx, and then we multiply that by the cosine of xy, because the derivative of sine is cosine. Then we can move on. The derivative of x is just 1, and that equals the derivative of y, which is 1, and once again we multiply by dy over dx. Next, let's simplify a little bit, so let's multiply out the brackets on the left hand side. So y cosine of xy plus x cosine of xy dy over dx plus 1 equals dy over dx. Next, let's take x cosine of xy times dy dx from both sides of the equation, so we can get the dy over dx's all on the right side. So that becomes y cosine of xy plus 1 equals dy over dx minus x cosine of xy times dy over dx. Then we can take out a factor of dy over dx on the right side, so just rewrite the left side like that, and then make the right side dy over dx times 1 minus x cosine of xy. And then you can isolate dy over dx by dividing both sides by 1 minus x cosine of xy, like this. And that means that dy over dx equals y cosine of xy plus 1 over 1 minus x cosine of xy. And that's how you do implicit differentiation.